Hello students, you are welcome to sirMATHS. Thank you for being around and joining in this very wonderful and thrilling journey, mathematics journey, where we are moving in the world of numbers. Today we are going to attend to grade 10, which is equivalent to SS1. And we are going to treat variation. When we are talking of variation, we are talking of a sort of an act of varying, an act of differing of maybe two or more things. A partial change in the form of position, state, quantity, in an equal proportion, or so to say. So under this variation, we are going to treat the direct variation and inverse variation and see the difference in these two aspects of variation. We still have two more: partial variation, joint variation. But for our grade, we just stop at these very two: direct variation and inverse variation. So we start with direct variation. We talk of direct variation when the two variables move in the same direction. What do we mean by that? When one variable is increasing, the other one will be increasing in equal proportion. When they are moving together, increasing, when one is increasing, the other one is increasing. Or when one is decreasing, the other one will be decreasing out of the two variables. We call it direct variation. For example, you are buying an item. Let's say you are buying this very particular writing pen, and each one is 100 naira, or it is $2. If one is $2, one will give you $2. When it increased to 2, of course, this will be 2 times $2. And when you increase the quantity to 3, this will be 3 times $2. You can see as the quantity increases, the cost increases in the same proportion. We call this sort of variation direct variation, where the two either increase together or decrease together in the same proportion. We call it direct variation. In each of these variations, we need to find the constant, that proportion, the constant. Let's have one or two examples. We are given two variables. Here we are asked, in a direct variation, y is equals to 18 when x is equal to 3. This is the information we are given. And we expected to find A, the constant of the variation. B, we are expected to write the direct variation equation. Write the direct variation equation. C, we are now expected to find, okay, for this very first one, let's solve these two. The information is when y is 18, x is 3. In our solution, we now say that y varies directly as x, which is y equals to kx. That is the constant we are talking about. Having done that, we now substitute the given values. Y is 18, yx is 3, and we are looking for k. We now say 3k divided by 3 is equals to 18 divided by 3. What you do to the left, you do the same to the right. We want to single out k and find a value. So the 3 cancel 3, that is k equals to 18 divided by 3 is 6. We have found a constant, and that is answer to question A. Question A. B, we are expected to write the direct variation equation. The direct variation equation. We simply say that y is equals to 6k, or rather 6x, because k has been found to be 6. This is our answer for B. For B. So y equals to 6 because k is 6, and that is 6x. This is the direct equation of this very particular variation. I hope that one is clear. Let us treat another question under this. Another question. Question 2. Example 2. We are expected to find a relationship. Okay, find a relationship between x and y. When y equals to 6 and x equals to 3. Thereafter, we are expected to find y when x equals to 2 and x when y is equals to 8. In our solution, we now say that y varies directly as x, where y is equals to kx, and y in this instance is 6, yx is 3k. Therefore, 3k divided by 3 is equal to 6 divided by 3. And 3 cancel 3, k is equals to 2, 6 divided by 3. Having found a constant, we can now find the relationship between x and y. We now say that y is equals to 2x. We have found the relationship that y is equals to 2x. Then we expected to find y when x is 2. Let's label it equation B. So y is equals to 2x as a relationship. And then we expected to find x, to find y when x is 2. So y equals to 2x is 2. So here y is equals to 2 times 2 will give us 4. We have found y when x is 2. Furthermore, we expected to find x when y is 8. Let's label this as C. We now put down the relationship. So here y is 8, and we expected to find x. So we have 2x divided by 2 equals to 8 divided by 2. Therefore, our x is equals to 4. Here we have been able to find the relationship between x and y. That gave us this. And we now find y when x is given as 2. Thereafter, we find y, or rather we find x when y is given as 8. This is our direct variation. Like I said, when the two variables are moving together, when one is increasing, the other one will be increasing. We call it direct variation. Let's look at inverse variation. Inverse variation. For inverse variation, the two variables will be moving in opposite direction, but in the same proportion. When one of the variables will be increasing, the other one will be decreasing in the same proportion. For example, between speed and time, we discovered that when the speed is increasing, the time taken to arrive at destination will be decreasing. But when the speed is decreasing, of course, the time that the journey will take will be increasing. The two, time and the speed, move in opposite direction. We call such movement inverse variation. Inverse variation. So I have explained to you what inverse is. The difference between inverse and direct. In direct variation, the two variables move together, increasing together. When one is increasing, the other one will be increasing in the same proportion. But for inverse, when one is increasing, the other one will be decreasing in the same proportion. Let's have one or two examples for this very inverse variation. Here we are told, in inverse variation, y is equals to 1 when x is equals to 4. So we are expected to find a constant of the variation. Thereafter, we expected to show the relationship between the x and y. Good. So, y varies inversely as 1 over x. Inverse. which is y is equals to k 1 over x, which is the same thing as k over x. So here we have y equals to k over x. Somebody can as well write it in principle. This is over 1. 1 times k is k. K is equals to xy. This is still the same. Now we answer the question. Here we are looking for k for question A. And k is equals to, like here we have xy. What is x is 4 and y is 1. So k is equals to 4. We have found the constant. And then we expected to show the relationship. So the relationship y is equals to k over x, which is y equals to k is 4 over x. This is the relationship between x and y in this very example. So we have found the constant. Let's label this as question A, and this is B. So this is our B, the relationship between the two variables. So that's y equals to 4 over x. That is for that one. So let's have another example. In this example, y is 1, yx is 12. And we're expected to find the relationship. Between x and y before we do that, find the relationship, we must find a constant. So for this is inverse. Y varies inversely as 1 over x, which is y is equals to k 1 over x, which is the same thing as k times 1 is k over x. We now substitute the values we have in the question. Here we are told that y is 1. This is k. We're expected to find first while x is 12. In principle, it's over 1. When we cross multiply, 1 times k will give us k, and 1 times 12 will give us 12. So the constant is 12. Then the relationship between these, that is y is equals to 12 over x. This is the relationship between the x and y, where y is 1 and x is 12. We first of all find the constant to be 12, and thereafter we find the relationship as required. And the relationship gave us y is equal to 12 over x. This is for a variation as involves direct and inverse. We are stopping here for today, and when next we meet, we continue our discussion. I still encourage you to subscribe to sirMATHS. Click to subscribe and notification button. You will be updated in this our daily discussion of mathematics. Thank you for participating today. We meet again next week by God.